questions on this one. The one thing I want to mention, and I saw on a couple too that I was looking through over. This is what you need to do to reduce it and get it out of there. And that has to stay there, that factor. If you graph just the end part without this, you're going to get the same graph. It's going to look exactly the same. But when you go to this table, this one, if you take it out, will have this point. It will have that point there, and it shouldn't, because that point shouldn't be there. So if you remove it out of your equation, then it fills that point in, because it is a removable point. So, and again, we approach the same sides from both, we approach the same point from both sides. But keep that in there. Another thing when you're doing this, this does give you this part of it. What gives you this part is when you do this, when you find the missing, the end part. Because you know your x is going to work, but you don't know what your y is going to be. So kind of keep track of that. That's why we do that for your point of discontinuity. My board is really off. Okay. Any other questions with this one? It's good. Again, put it in your calc. Take a look at what your calc does. This one, and a lot of you were unsure if it looked right. It looked simple. It was simple. The zeros, you find the zeros in the numerator. Set those to factors. Okay, so the first thing we're going to do is set these guys to factors. Start with that. So now you got your zeros. You have no vertical asymptote. You have no restriction in the denominator. So let's remember that. Your horizontal asymptote says y is equal to -3. So you had some relationship like this with your x values. So if this is an x squared, I'm going to put my -3 here. This gives me -3x squared. So right away I know I need an x squared down there in my denominator. But now x squared gives me a restriction. So add whatever you like to it. I just always put 1. You can put whatever you like to it. You may change your graph, it may change the look of your graph, but all those characteristics will still be there. They'll still be there. No, go ahead. They'll still be there. So work with whatever's easiest. Also, sometimes you see these, they give you a 0, and you might need this point, or you might need this point. So sometimes there's 2 ways to look at that. If you have to plug it back in, that also gives you a point that you can use, an XY point. And
when you put that in the calculator and then put that as y equals -3, it like goes under.
And it can. Remember, it can jump over, but then your asymptotes are designed for your end behavior. So what happens in my asymptotes, if this is my asymptote, and my end behavior should go alongside of this, right? Sometimes what happens, and I'm all on the same color, sometimes what happens is it jumps over this, but it still comes back down to use this as end behavior.
So horizontal ones, they can jump over, the verticals, they can't.
Right. Verticals, they can't, because that's a denominator restriction. And you'll always get a 0 there. So you can't do that. Which is why once we remove your point of discontinuity, we take that factor out of there, that you still can't use that x value. So then it comes out as a point of discontinuity instead of a vertical asymptote. Makes a little sense now? Our asymptotes are designed for end behaviors. The one thing I could remember the most that you guys would relate to is your trig. So here was your trig, and say you did the tangent function. These are by 90s. Did you have a value for the tangent of 90? You didn't do... You never graphed it? Yeah. Oh. Okay. All right. Whoa. Okay. How about did you make ellipses? Hyperbolae? And her side? No, hyperbolae. So technically you probably didn't have much need for an asymptote, right? What did you do for asymptote? asymptotes last year?
We have exponential.
Okay. Logs, exponents and logs. A log and an exponent. Okay, you made an exponential curve, right?
Yeah, it was less.
What happened here? Why does it not cross over here? There's a natural asymptote at y equals 0. And basically, it is because I can't get a 0 out of y, right? I can't, whatever exponent I put in, I can't get a 0 out of y. Then you did your logs, which went the other way, right? Did you do logs? You hate those. All right, we'll work on logs. I think that's our next unit. But then your asymptote swapped, because instead of a y equals 0, you became an x equals 0. That was your asymptote, and it guided your end behavior. It guided where those ends were. So we basically do the same thing, but we find a case where it's okay, we can jump over this, but we're still going to use this to guide our end behavior. Our slant one works really nicely too. When you have a slant asymptote, generally what happens is your graph comes right in here. It uses both of those to guide its end behavior. We're also going to do ellipses, circles, hyperbolas. In a hyperbola, we generally say, okay, we make this box, and we put these diagonals through here, and these act as asymptotes, so we can actually make your hyperbolas off of them. Maybe you saw something like that. No. Okay. Maybe you saw nothing like that. God bless you. Don't worry, we'll work on those. But when we do get to those, I want you to make sure you tell me, like when we start working on them, that you're not comfortable with them. You didn't do 4 or 5, right? Okay, good. Where did that vertical asymptote come from? A denominator. We have a vertical asymptote from my denominator, and we have a slant asymptote, and we have a 0. Where did my 0 come from? My numerator. It also could be the point for 0. Remember, we said a 0 could be the point for 0. Means it's going to cross that x-axis somewhere, right? Somewhere at that point. Now, a slant asymptote. How did we find our slant asymptote? Synthetic division. We took a root of the denominator, which in this case would be 2. We put all your coefficients out here from your polynomial, and we did a divide. And somewhere we came out with this. So lift out your coefficients for a minute. This is going to be, I'm just going to put the x right next to it. And it had a remainder, right? And did we care about the remainder? No. Now we care a little bit about the remainder. And we took this remainder and we put it over the denominator. Good so far? Because usually they have a remainder and we don't care about it. If the remainder is 0, we'll still see the 0 here. We'll still see a 0. If it was a 0, we'll still get a 0 here. Usually when we do a synthetic division, we don't care what the remainder looks like. We just care about this part of it. Now, so therefore, this started out with 1, came down, we divided, blah, blah, blah. We need to work ourselves backwards from this, because this is really the only thing that we know that'll help us with our slant. So therefore, we're going to take something, and we're going to find what our r used to be, because that's going to help us figure out this part over here somewhere. We're going to find out our r if we can eliminate our x and our y. So we've got to have one point that's going to help us, and that's going to be this 0 point. So that's why I said before, sometimes you see it in the numerator, sometimes it works as an actual point, where this is your x, this is your y. So we're going to work with, on a slant, we're going to work with our synthetic division, because that's what gave us that slant. So we're going to, and remember, when we did the slant, we had your whole polynomial up here. So if we can reverse this process, we should be able to get back to your polynomial. So let's plug in the x and the y into this. Every time you see an X, plug in a 4. Every time you see a Y, plug in a 0. Now, when you work through this, you're missing your R. So we're going to solve for your R. Well, how would I solve for R in this case? Oh, sorry. How would I solve for R? Subtract 3. I can subtract 3 first. And multiply both sides by 2. Doesn't matter what order you did that in. So I found R. So I'm going to bring this guy over here. Okay, I'm going to bring this guy over here. And this is what we have so far. Did we ever leave this like this? Do you see your rationals left like this? What does your rationals usually look like? How many terms? It's one big divide thing, right? So we got to get this down into one term. So let's just put this over 1. We're almost there. We never see it left like this. Same thing like we never leave fractions. We never see fractions in your quadratics or your polynomials. They multiply them all out. So we're just going to get rid of this denominator. We're going to make this one denominator. Oh, and that denominator looks like that denominator. Right? So I'm going to take this guy, put it over 1, just group it together, put it over 1. This one needs an x minus 2. So I'm going to multiply my numerator. I'm going to hook it up like that, times x minus 1. Minus, this guy already has the denominator. All I need is this. We're really close, but we also never see this either. So we're going to distribute this out. And don't forget your y equals f of x equals g of x equals whatever you like to, but it has to be an equation. And just collect your like terms. Okay? Now, once you get here, you can put this in your calculator. And I would put my slant asymptote in my calculator as well. Your vertical asymptote, you can't, but this you can. We can even factor this. See if the zeros come out to be 4, 0. Again, put this in your calculator. And put your slant asymptote in there. Your slant asymptote works nice too, because you can see where it's going. If it's off, you will totally see where it's off. This one's not that bad. It just looks a little different. And you have to remember, we always have one rational, one term. I'm going to put the slant next in the next one. God bless you.
Thank you.
I don't know what my graph is like before. So here goes my graph. There's my slant. Do you see my end behaviors working pretty well here? Do you see what my graph is doing? This is my slant asymptote right here, this line. So it's guiding the end behaviors of this graph. Do I cross? Do I have a 4, 0? I have a 4, 0, so that's good. And an x equals 2. A vertical asymptote. Can you see where your vertical, ignore this, let me take this out for a second. Can you see where your x equals 2 asymptote is? Can you see what's happening right here? Something went up like this, but then caused it to break and come back down here. Here's your x equals 2 asymptote. That one you can't graph because it's an x equal, but you can take away the slant, you see it better. Good? Alright, why don't you guys try number 5? You guys try number... We need to record this for the people that aren't here.
Oh,
I'm Gabby.
Hi, I'm Gabby. I'm doing it for you guys.
I'm sorry, I can't hear you. You're not facing us.
Well, when we put you up there, you're going to see how hard it is to write and talk, put the right words out there and the right numbers out there. I feel like I talk to the board sometimes too, but if you're not facing it, you can't write on it. Okay, so she's using her synthetic division, because that gave her her slant asymptote. Did everybody see what she did? She plugged in the point 0,
That's a
negative
little
3,
slanted,
I mean negative
my
3,
bad.
0. That's okay. You're doing very well.
Thanks. Are you judging me?
No, we're judging the other gym.
So the no judgment zone.
We plan fitness.
I pick things up very quickly. Thank you.
Anytime.
Very nice. Thank you. Okay, so this is a good way to start, just so that you have a reference to where these go. And if you factor that, isn't one of those factors x plus 3? X plus 3, x minus 2? The x minus 2 just is a bonus thing that we got in there, but we did have the x plus 3, we do have the x minus 1, so it is there when you're done. It just, we have to work everything out because we don't leave any fractions. So she started with her synthetic division, plugged in her x that she knew, her negative 3, 0. The y was 0, the x was negative 3. She found r, brought it back here, common denominator, put this all over 1. This is what makes this a rational. Multiply it by your x plus 2 times x minus 1. Work that out, combine your 4's, and then you're left with that. Graph it, you should see your negative 3, 0. Put your asymptote in there, you should see where your vertical was coming from. Okay. Questions?
Yeah. When she plugged it in after that, right there, where did you get x minus 1?
So she went back to this, and she went back to her original. She's here. Now she plugs in her negative 4 right here. So she gets x plus 2 minus 4, well, let's give it a plus negative 4, whatever you want to do here. Now, you have to get this all into 1. We have to make it one rational, one denominator. So we put this over 1, we just grouped it together. We made a common denominator of x minus 1. So then she looked at her first term and she said, okay, I need to make this over x minus 1 instead of over 1. I need to multiply top and bottom by x minus 1. There's my x minus 1 now. So this she's FOILed out. The 4 had the x minus 1, so we just dragged it over. And then we combined like terms.
Is it next to the synthetic division? I was supposed to write 1. It's in negative 3.
I don't know where you are.
When she did the synthetic division all the way to the top, she's saying it shouldn't have been 1 instead of negative 3.
Oh, this should say 1, but that's okay. That's all right. It doesn't really affect you because you're not doing a synthetic division. Yes.
I don't get why.
Because, do you ever see an equation that's left like this? Do we ever leave an equation like that?
No, I get why, like, I don't get why we have to write, like, the one and then, like,
The one,
like, write out, like, you're doing something.
where are you?
Like, where we just were, like, how you change it to a one, like, I don't get why we put
All the way
the
to the
one.
top right. Top right.
When we talk,
Oh, why we put the one?
and, like, the box. And
You really don't have to, you don't have to put the one here because technically that doesn't matter to us right now. What matters to us is we need a starting point. And our asymptote, our slant asymptote, we know where our vertical asymptote came, denominator. We know where our zeros come, numerator. Our slant asymptote came from a synthetic division. So our goal is to get back to all these coefficients. We know what the denominator is going to be, but we need to get all the coefficients back. So technically, this is what you ended up with. Really 1, 2, plus a remainder, which we don't know. We do know this part because this came from here. We do know this part, and we don't know what our remainder is. Our remainder will help us get back to whatever was left over. So technically, you divided by your 0 of your denominator here, but that doesn't matter because you're not going to use that 1 up there. What you're going to focus on is this piece right here. As soon as you set that up, you're going to say, well, there's my y equals x plus 2 plus my remainder, which I really didn't care about before, but it will help me get back to my original equation. So now I substitute any point in there, which this one they happen to give me. There's my x, there's my y. So we substitute it in and we solve for r. And then we go back and we combine everything that we knew into this, into your slant asymptote. That's the only thing we can get back to. That's what gets us back to our original equation. It's kind of a backwards approach. Does that explain it?
yeah.
This is important because it's a 0 in the denominator, but it's not something that we need to solve this problem right
So
now.
we still need to write, like, whatever number it is and then, like, the box.
You don't have to. I mean, as long as you go like this and write your equation down here and start like this, you need that denominator. You need the denominator, the x minus 1. So always start like this first, which is whatever information you have, start setting up because you need this in that denominator over there. And that's the piece you're going to work off of right here. Okay. Make sense? Okay, good job, Daddy.